Okay, it is a new topic. We are going to discuss the chi-square test in chapter 13. Before discuss the chi-square goodness of fit test, I want to introduce you. It's something, it is not a new one, but okay. Before, one day I gave you a statistical model. Any kind of a statistical model has the response variable y and x. Then we are thinking about the function of x for the y to explain the y. But in statistics, it's always we have some error. And also I made a table. Here is a y and x. X and y's are the variables, but in statistics we have only two kinds of the variables. As one is the continuous, the other one is the categorical. I'm sorry, it's not continuous, it's a numerical and categorical. And also the x, the independent variable, it can be numerical and categorical. It's already we discussed the numerical y and the categorical x, that is the ANOVA, the analysis variance, or t-test, the independent two-sample t-test. And the numerical, that was the regression model, right? But now the chapter 13, it is the chi-square, that is the categorical and categorical. It's a chi-square, that is the chi-square. That means we are going to use the counts or the frequencies. So based on the counts of frequencies, we can do the test. It is the categorical and categorical case. So that will be the chi-square test. Okay, it's good. So let me go back to here. Here's an example. It's actually here's the types of the violation. So we have 4 types. And it is the frequencies, it is the counts, is from the 500 sample. But this one is another, the distribution. It is a distribution, it's the same 4 categories, the 4 types of the violation in 2010. Okay, actually this one, the table 13.2, it is the frequencies from the 500 random sample, but that it was in table 13.1, it is a distribution in 2010. So now, it is a testing again. So absolutely, we are going to apply the 5 steps. So in step number 1, we state the null hypothesis and alternative hypothesis. So please look at the null hypothesis. The last year, the violent crime distribution is actually, that is this one, the last year. That is the last year. I mean the frequencies. It's the same as the distribution in 2010. So sometimes the moderate type is increasing or decreasing, or any other type is increasing, decreasing. So we want to test if they changed or same, right? So here's the proportions, and that is the frequencies from the random sample. So we compare the 2 distributions. One is the last year from the sample, and it's compared to the given data, the given proportion in 2010. Absolutely, the alternative hypothesis is different. So it will be the two-tailed. So it will be the step number 1, state the hypothesis. And let me go to, yep, it's a. So now it will be the test statistic. It is the second step. Just a second, what's wrong? Okay, it is the second step, the test statistic. To get the test statistic, we need the observed count O and expected count. And expected count looks like this one. As N is a sample size and P is the proportion. So let me try. Yep, here's the work table. So let me try to get the test statistic. It's here. Here's the 4 types of the violation, right? And it is the observed, the frequencies is out of 500, and that is the proportions, the relative frequencies, the proportion in 2010, and that is last year. Okay, now we can take the expected count. Now I will take the expected frequency, that is the sample size times the proportion. It's actually the relative frequencies, that is the proportion, and 500, that is a sample size n. So I can take the multiplication. It's a 500 times the proportion, 0.012. Just a second, I need a space. Again, 500 times is 0.012. That will be just 6. And the next one is a 500 again, and its proportion, probability, 0.068. That will be 34. And just keep going. The sample size, 500. Its proportion, 295. And that is the 147.5. And the next one is a 500 again, times is a 0.625. Then the multiplication will be 312.5. So when I add up the 6, 34, 147.5, and 312, when I sum up, that is a 500 again, because when I take the sum up, the proportions, that will be 100%. So we multiplied for each, then sum up is 500 is again. And the 6, 34, 147.5, and 312.5, they are all expected frequencies. That means when we apply the proportions in 2010 to the sample size, then we can expect the 6 murders and 34 the next one, the forcible raped, and the next one is the expected value, the expected frequencies is robbery, and the next one is the expected count, expected frequencies. Okay, so finally we need the chi-square, the subtotal, because it's actually the sum up, it's actually the summation of the observed one minus the expected one square over the expected one. That will be the test statistic, is a chi-square. So now I need the difference. Yep, here. Before, take the square. So the observed one, 3, minus the expected one is a 6. That will be negative 3. And here's a 36, observed 1, minus we expected is a 34. That is a positive 2. And the next one is 170 observed minus expected is 147.5. That will be positive is a 22.5. And the next one is a 291 minus the expected one is a 312.5. That will be negative 21.5. And now again, when I take the sum, negative 3, positive 2, positive 22.5, and negative 21.5, as always, that will be 0. Then now we can take the square. That means take the difference before. Square will be 9. And positive 2 square will be 4. And 22.5 square. And negative 21.5 square. You know, in this case, it's always we can take the positive squared value. Then now divided by E. So expected one E was 6. So 9 over 6, it will be 1.5. And 4 over 34, that is 0.1176. And take the square over 147.5. That will be 3.4322. And take the square over the expected one is a 312.5. That will be 1.47 is a 92. Then what? Take the sum. Take the sum, right? Yeah. So the summation will be 6.529. So that is the test statistic. In step number 2. Then now step 3, we need the p-value. It is the chi-square test because we are going to take the probability from the chi-square distribution. The chi-square is a right skewed, it's non-symmetrical, and always we need the right tail probability. To remember what was the alternative hypothesis? In alternative hypothesis, we stated if they are different, it was the two-tailed. Can you remember the alternative hypothesis in analysis of variance in ANOVA? Yeah, the F distribution looks like this, but it is the chi-square and it was the F distribution. But even we stated it's like as the two-tailed, but we just take the right tail, only the right tail for the p-value. It's almost the same idea, even though we stated alternative hypothesis is not equal to, but we are going to take only the right tail probability for the p-value. We don't have to take twice because it is not symmetrical. It is only define the positive part, right? Then now the test statistic was 6.529. Then now we need the probability, the right end. For the p-value, using your calculator, so if you have a TI-84, please go to the distribution. Please, you have to click the second and click the distribution. Then you have to, there is a list from the normal distribution and the t distribution, something is going down. Then you can take chi-square CDF. The chi-square CDF asks us the lower, upper, and the degree of freedom. It asks us the three parts. So the lower must be 6.529. It's going to positive infinity. So most of the time I plug the upper one is 9,999. And now, like as the t distribution, we need the degree of freedom. You know the degree of freedom, that is a c minus 1. The c, that is a number of categories. So let me go back to the table. We had 4 categories. right? It's actually C is the 4. So now the degree of freedom is 4 minus 1. That would be 3. So you pick chi-square CDF in the list of the distribution in TI-84 calculator and plug the lower value and upper value and the degree of freedom C minus 1, 3, then you will get the p-value 0.0885. Don't have to. Do not take twice. It is the p-value. Then now we have to make the decision. So it didn't give you the p alpha, then let me give you the alpha. The significance level is 5%. Then the p-value is bigger than 5%. So fail to reject the null hypothesis. Absolutely, the p-value is less than alpha, less than 5%, then we can reject the null hypothesis. What was the null hypothesis? Let me go. Oops. Yeah, I don't know. The null hypothesis was this. There are same, but we did not reject the null hypothesis. So I have to make the conclusion. They did not change. Yeah, they did not change. So the idea was here. We observed last year we observed the 3, but based on the proportion in 2010, we can expect the 6. So the difference is only -3. We observed last year the 36 for the second type, but we expected 34 is based on the proportion in 2010. There is only 2 difference. We observed last year's 170, but we expected as a 147.5, and the difference is a 22, and the next one is a difference is a 21. So now finally we did not reject the null hypothesis, and we made the conclusion there is no change because the difference is relatively statistically is very small. But it's not just to take the difference between the observed one and the predicted one. The expected one. But we just take the ratio. We just take the square and divide it by the E, and just to sum up, get the test statistic, the chi-square. And based on the chi-square distribution, we got the p-value to make the decision, right? So it is the procedures. For the chi-square test one. And here's a summarization. The step number 1, state the null hypothesis and alternative hypothesis. Always the textbook give us the second step to determine the alpha, and step 3, but I gave you the step 2, the test statistic, and step 4, get the p-value to make the decision and the conclusion. Okay, so it's the same 5 steps. We can apply the chi-square is a goodness of fit. It's a goodness of fit test means we do the test for the fit. We compare the last observation to the proportions in 2010. So we test the fitness is between the 2 years. So we need the observed frequency and the expected frequencies, right? So this way, we take the test statistic chi-square, and we take the p-value from the right squeezed the chi-square distribution, and based on the p-value, exactly same way to make the decision and the conclusion.